For Chapter 9, Section 2, we're going to continue to talk about how to graph these quadratic equations, but we're going to focus on finding two key things for our graph that will make it a little bit easier for us instead of having to just rely on tables and looking for those values that we were doing in the first section. We're going to talk about something called the axis of symmetry and the vertex today. We're still going to be using these quadratic form, so remember what we saw previously was when you had something like ax squared plus bx plus c. So you had that x squared term, the x term in the middle, and then your constant at the end. And so we're going to still use that form to help us find these couple of things. The first one is that axis of symmetry, which I did talk about in section 1, where that's that imaginary line that goes through the middle of the graph and kind of cuts it in half on both sides so that it's making it even on the left and on the right side there. In order for you to find where the axis of symmetry is, you're going to want to use this equation right here. So you're looking for the x value because the axis of symmetry is going to cut through the middle of the graph and it's going to go through your x-axis. And so when you're finding your x, you're finding that point on the graph that's going to cut it in half. And to do that, you're going to use this equation of negative or opposite of b all over 2a. Now where the a and the b come from is up here in your quadratic. So a is always the number that's in front of your x squared and b is always the number in front of your regular x. So whatever those numbers are for your equation, you're going to plug them into this equation to help you find that axis of symmetry point. Now in order for you to find the vertex then, you're going to take that value that you found for the axis of symmetry, so we're going to take that x value, we're going to plug it into our equation to help us find the y value. So the axis of symmetry is going to give you the x coordinate of your vertex. And then once you have that, you're going to plug it into your equation to help you find your y so that you can see that coordinate x comma y for that vertex point. For example, if I have this equation right here, y equals 2x squared plus 4x minus 3. I would first just kind of get in the habit of identifying like what's your a, what's your b, what's your c. So for a and for b here, a remember is always in front of x squared, so that's going to be 2. And b is always going to be in front of x, which is going to be 4 for this one. And c is going to be negative 3, which we don't really need right now, but just, if it helps you to kind of go like this across your graph or your equation so that you can see where your a, your b, and your c are at, because c will come into play later as we start to find other things that we're looking for. But so our a for this one is 2, our b is the 4, so now we're going to plug in our numbers to that formula from up above. So remember that formula said opposite of b or negative b over 2a. So using our numbers here, in for b we're going to put a 4, and it's going to be negative. It's always going to be the opposite of what that sign was, over 2 times a, so 2 times 2. Then you can simplify, so we'll have negative 4 over 4, which will simplify again down to negative 1. And this is going to be your x value. So not only is that going to give us the axis of symmetry, that line that goes through the middle of the graph and cuts it in half, but this is also giving us the x coordinate of our vertex. So now that we know what x is, we can use that to help us find y. So we're going to go into step 3 here, use our x value that we just found, negative 1, and we're going to plug it back into the original equation. That came from up here, what I highlighted in that yellow color. Now I'm going back over in green. So in all those x's, you're going to put in a negative 1. So it's going to look like this. Y equals, we have 2 in for x. So I'm going to put parentheses around this. I'm going to do negative 1. Squared, and then we have plus 4. Again, parentheses, I'm going to put in a negative 1, and then minus 3. Now, if you wanted to, you could type all of that into your calculator, and especially if you typed it in with the parentheses and everything, your calculator is going to go ahead and spit out the answer for you. But if you need to split this apart into smaller steps, do your squared, do the multiplication, kind of follow your order of operations in order to help you make sure that you're getting the right answer. When you do this math, whether you type it in like this on your calculator, you break it apart piece by piece, you're going to end up getting y equals negative 5. So my vertex is going through that x value that we found up above. that we plugged into our equation here, so that -1, and the y is going to be what we just found, that -5. So a couple of things is you've got your axis of symmetry is going through x equals -1. So that means where our graph is going to be, the middle is going to be to the left from 0, 0, 1 spot. That's going to be that imaginary line that goes down the middle. The vertex is this point exactly. So that's that turning point that we talked about yesterday, where the graph is going to open up or it's going to open down. That's going to be either a minimum or a maximum for this graph. Now, the last thing that we can find is that y-intercept. So remember how earlier I was saying identify your c value. So in that equation up above, you can put zeros in for all of your x's. So you've got 2 times 0 squared plus 4 times 0 minus 3. What's going to happen here is because you're multiplying by zeros, these first two terms are basically going to eliminate, and you're going to be left with just that -3. So remember how up here I had labeled them A, B, C right here? So that C value, that -3, is going to be our y-intercept. So you can always think of like putting zeros in for x's, but a fast way is just to grab that number at the end, which is a -3. So my y-intercept is going to be always 0 first, because that's what we had put in for x, and then that -3 or whatever that number is at the end of your equation. So now what I'm going to do is show you how to graph using those couple of things that you found, using your axis of symmetry, using your vertex, and using your y-intercept. So instead of us having to make big tables like we did yesterday, we can use these couple of pieces of key information for our graph to help us see where it's going to be at. So remember, our vertex from up above was that -1, -5. So I'm going to start there. So I'm going to go -1 on the x and then down 5 on my y and draw my vertex point. So right here is like the center of the graph. This is also where the axis of symmetry line is going through. So imagine that invisible line cutting through the graph right there. This is going to be the middle. The other point that I know is that y-intercept, which we found to be at 0, -3. That means that you're just going to go down 3 and draw a point. So if you remember from section 1, when we talked about that axis of symmetry, that is it's right down the middle of the graph. So everything on the right is going to have something on the left that is a mirror image of itself. So when I see this point at 0, -3, notice how that's one space away from that green dotted line, that axis of symmetry. So that means that there should be another point one space to the left. So I can draw another point right there. And then what I can do, because I've got 3 points here, is I can sketch in the general idea or general shape of this quadratic. And remember, all those quadratic graphs have that curved V shape. They've got that U-ish kind of shape happening on the graph there. So this is just a little bit of a simpler way of graphing by finding a couple of those key things so we don't have to rely on making such big tables all the time. So on the next page here, we've got a couple of practice problems. And what I want you guys to do is take a couple minutes and try to do this first one, and then we'll go on to the next one. And I want you to try to find those same things. Find your axis of symmetry, find your vertex, find your y-intercept, and then give me a sketch of your graph. So I would go ahead and pause here, and when you're ready to walk through the solution, you can resume watching the video. So for this one, again, if you needed to, identify your A, your B, and your C right away. To start with your axis of symmetry, you're going to use that opposite of B over 2A equation. So opposite of B would be 4, and we're going to negate it, so it's -4. And your A is also a 4 here. So we have -4 over 2 times 4. This is going to simplify to -4 over 8, which will reduce to a -1/2. Now, just because you got a fraction doesn't mean that you're going to handle this problem any differently. It just means that when I go to graph my vertex, I'm not going to be at like a whole number point. I'm going to have to kind of estimate where I think that -1/2 is going to be. To find the y coordinate, this is when you're going to want to plug in that -1/2, that -1/2 for all your x's. So again, when I type this in on my calculator, I am putting parentheses around those numbers that I'm plugging in, and I would advise that you guys do the same so that your calculator knows exactly how you want it to be figuring your answer. When you do this here, you should have gotten y equals 0. Okay, so your vertex is going to be at that negative 1/2, comma, 0. The y-intercept, which is the other kind of important thing that we need to help us graph these, is that c value. So that's that number at the very end there. So you're going to put 0 always in for your x, and 1 goes in for your y. And again, that's the same idea as if I was putting zeros in for all those x's up above. Okay, so now I'm just going to draw my sketch of my graph over here. Again, my vertex is at negative 1/2, so I'm going to go over half, 0. That's going to be the middle of my graph there. If it's helpful for you guys to draw in that axis of symmetry line that goes through that, go ahead and draw that dotted line in. Especially for this next point, because 0, 1 is that y-intercept. So that's about half a step away from that dotted green line. So we're going to go half a step to the other side to draw the reflected point, and then go ahead and sketch in your graph. So that one should have looked something like this one. Okay, go ahead again and take a minute, pause the video and do this one, and then resume watching when you're ready to see how it should look. Now with this one, we have this negative x squared. So your a is really going to be that negative 1 that's sitting in front of the x squared there. Your b is going to be 4. Your c is going to be 4. So to get you started with the axis of symmetry, using this equation again, we're going to do opposite of b, so negative 4 over 2 times a, which we said was that negative 1 that's sitting in front of that x squared. So this, because I have a negative over a negative here, is going to end up being positive 4 over 2, which is 2. Now to find my y, we plug 2 in for all those x's. So I have a negative, and then I'm putting in my parentheses, that 2 squared, plus 4 times 2, plus 4. When I did this, I got y equals 8. So my vertex is at 2, 8, and that's just coming from these two pieces right here. Now your y-intercept, that's your c value, which I have up here as the 4. So it's going to be 0, 4. So I'm starting at my vertex, I'm going over 2, up 8. Drawing that point in. Then we've got one at 0, 4. Again, if you need to draw that axis of symmetry line in, especially when you're trying to reflect your y-intercept point, just draw that dotted line in. We see that this time the y-intercept is 2 to the left of the green dotted line, so we want to go 2 to the right to draw the reflected point. And this graph is going to open upside down. And the reason for that is because of that negative in front of that x squared. That causes this graph to reflect itself, so it's going to flip it upside down instead of opening up like we saw in the last couple of examples.